right. What questions did we come across on the homework? Yo. 12. All right, number 12. Going there. Ooh, that looks like a tricky one, huh? All right. Problem number 12. Shh. Hush up, you guys are chatting too much. Shh. Bad kids. How excited there was a snow day. Delayed start today. Alright, so that's S, that's Q, that's R, that's QV. So they tell us that SQ over SR. So SR is 7, SR is 7, SQ has to be 7 plus, or let's do this, X minus 7. So if we call this little part right here X, that should work. Is that okay so far? And then that's going to be equal to TV, which is 10, over TU, which is 3. And then we should be able to solve that by cross multiplying. 3x minus 21 equals 70. 3x equals 91. X equals 30.3 repeating. Is that right? Is that what they said the answer was? 49 over 3.
Oh, I can tell you.
Yeah.
Okay, so what I did was I did x over 7 equals 7 over 3. And then I cross multiplied and got 3x equals 49. And then divided by 3 and got x equals 49 thirds.
Say that one more time.
Yeah. Okay, so I got x over 7
X over 7
equals 7 over 3. And then I cross multiplied and got 3x equals 49. And then divided by 3.
I would agree that would get you 49 over 3. But I'm not seeing how, because this is only a part, right?
Yeah.
And then this part says part over, or whole.
Because you're doing part over part. I don't know.
Oh, wait a minute. What about if this? Oh, you know what my mistake is? This. That should be a plus. If that makes that a plus, that makes it a plus. That makes that, is that right? 49? There it is. I have a sign error. All right, what else? Yeah. 3. All right, 3. They say that x over 6 is equal to y over 15. So then they said that x plus 6 over 6 is equal to question mark over question mark. Okay? So we know that these are equivalent to each other. So I would do your cross product first here. So I'd get to that, knowing that's what I have to get to. Okay? So x plus 6 over 6. That was really question mark over question mark? What did they say the answer was? X. So this should then be y plus 15 over 15. And the reason why this is going to work, I'm going to show you. Okay, so notice the difference here. They took this and added it. So we're going to take this and add it. The reason why this is going to work, if I cross it, then I'm going to get 15x plus 90 equals 6y plus 90. If I subtract the 90s, I get 15x is equal to 6y. And that verifies that it works. Yeah?
Can I ask another question?
Sure.
Okay, for number 2.
2. Okay? So we're trying to get, so the cross product of the first part would be 20x equals 9y. So then you would have 9 over 20 as your question
yeah,
marks.
You just switched it.
Yeah.
Number 4.
4. 4 is going to be done very similar to this one. Okay, so they did, so think about what the cross product here would be. 14y equals 3x, right? No problem there. So what do we have to do? What's taking place? And what they're doing is you are going to go with, that's going to be what? X plus, hang on, I can do it. Which is 17, which that should work. So what I did was, let's see, is that going to work for us? Four. Oh, they want x plus 5. All right, so what do you have to do to this in order for this to happen? You have to, denominator stays the same. And what do you have to add to it? So that's why you're going to go, and you're assuming you have your x and y's this way. So this is an x value and this is a y value. What do you have to do to that x and y in order to get to that? And that's kind of the lead on that. What else? Yeah.
15.
In science class, the ratio of men to women is 5 to 4. There are 63 total students in the class. How many men are there? You have men, women, add ratio 5 to 4. So I would think, so 5 to 4 is men to women, and then you have a total of 63 total. And we need to get down to finding that we have 35 men in the class. I think we have to change the ratio to be either all men or all women. Being we're trying to solve for men, we'll keep it as men. So if the ratio Yeah, 5x plus 4x equals 63, like that. And then that's 9x equals 63. So x is going to be equal to 7. So then you'd have to go times 7 here for the men. Yeah. Cool. Yeah.
Would it be alright if we did it that way instead of using proportion?
Yeah, that one, that way's going to work for me. Well, we'll just say that we're counting things, so we'll call the things x's. In this case, they have to be men and women. It just has to be a relationship of you have 5 times as many and 4 times. For every 5 of these, there's 4 of these. Just have to do men and women. Yeah. 8. X over 4 equals, okay, decide if it's true or false. Okay, so the best way that you need to determine if that's going to be true or false is just cross multiply. So 4 plus x over 4 equals 3 plus y. So if you cross that, that's going to give you 16 plus 4x equals 12 plus 4y. And you could leave it like that, or you could start simplifying it down. So you could have a 4 plus 4x equals 4y, which then I guess you could take that down to say this. So as long as my next one can get us to any one of those, we are good. X over 4 equals, what is it? 3 over y. Okay, by cross multiplying this, I want it to equal any of those. So x times y equals 12. It's not going to happen. So they are not equivalent. Is that right?
No, it's true.
You got a true? Did I goof? 4 plus 4x. 12 plus 4y.
Oh, because you get 16, or not, you don't get 16, you get 1 plus 4x equals,
1 plus
Wait,
4x.
yeah. wait.
All right, so maybe let's break apart the fraction. So 1 plus x over 4 equals 3/4 plus y over 4. I start breaking across the fraction.
Wait, but it's not supposed to be yeah, it's supposed to be a y.
Where's a y?
3 plus y over y.
This is a y?
Yeah.
Oh, that kind of changes things.
So then you get 1 plus
So 4y plus xy equals 12 plus 4y. Subtract the 4y, so xy equals 12. Xy, oh, that works. It works when I read that y and 4 are not the same thing. Sorry about that. Anything else?
Can you go back to 12? Oh, yeah, we did that.
Is that 12? That 12? I didn't write it.
It's the 49 over 3. Yeah.
Okay, make sure your names are on those. And your homework came back out to y'all, right?
Yeah.
Cool.
Oh my gosh, this kid.
So, while you guys are handing those forward, I want to talk to you a little bit about something that's going on. So I grew up with a guy, his name's Robert Barnes. That's his son. So, starting, they are now a handful of days into this. They are walking from Florida to the state of Washington. Walking. So if you kind of take a general look at the map, they started down here. They're going to walk all the way across the United States, the state of Washington. The son, was diagnosed with diabetes. So this coming Saturday, they're doing a 5K run in Key Largo, Florida. The whole walk is 3,925 miles. Look at. July 8th is when they'll be here. They will finish this walk October 28th in Blaine, Washington. So think about that. Why are they doing it? Well, the son, when he was 18 months old, was diagnosed with type 1 diabetes. They're doing it for diabetes awareness to raise money for research. I think it's unbelievable. So they right now have like 30 or 40 people just this week who have started walking with them. Yeah.
This reminds
Can
me
they just not stop walking, or do they like stay until
Well, his wife will drive the motorhome like from here, and then it'll go, okay, I'll meet you 15 miles down the road. And then they'll stop for the night. And then same thing. And so the two boys are being homeschooled for the year. Which, you think about that. Like, I mean, is that going to be a pretty big event? I mean, I think a 10-year-old kid walking across the United States with his dad sounds pretty amazing to me. So I think I might, once they start getting into right around the vicinity of Colorado, I might take a Greyhound bus out to wherever they're at, and I'll just walk in with them. Because if they're in here in July, I think that's pretty cool. Yeah.
Does this remind you of Forrest Gump?
Well, no, Forrest Gump didn't do it for a reason. Yeah.
Like the running.
Yeah, Forrest Gump was based on fictitious.
They're
Yeah.
running, like, how does that raise money?
People sponsor them
To run?
to walk it, yeah. And every Saturday they have a 5K run. And the 5K run, that's a fundraiser, and so it creates awareness. So they're hoping to raise $150,000 doing it, which I'm sure they will without a problem. But I just thought it seems like a pretty cool thing. All right. So when someone says, "Wow, I had to really walk far," well, I think Noah Barnes has got us all beat. There was some bridge in Florida coming out of the Keys that they had to walk on the other day. It was a 7-mile bridge. You guys complain about walking from here to the East Building.
That's a far walk. Especially cold.
They're fortunate they started in Florida, so it's probably in the 80s right now.
They started what?
The walk. No, you walked out when I first started. 80 degrees.
How hot do you think it's gonna be in Hawaii? 90?
No, like 70.
I heard it was 80, but it felt like 90.
All right, guys and girls, notes are coming out. Let's do these. Let's see, we are out of here at 12:07, plenty of time. All right, similar polygons. So again, a quick reminder, similar means that we are maintaining the angles, not the size, right? So similar should look the same, just one bigger than the other. Thanks, Bob. All right, develop an understanding of properties of similar polygons and use the understanding to find the missing measures. Woo! First, some more practice on geometric means. You must include a proportion, express your answers in simple radical form. Finding the geometric mean of 5 and 30. You should be all okay saying this. So that leads us to x squared equals 150. So x is equal to the square root of 150. Rationalize this, right? 25 goes in both top bottom, so 5 root 6. Is that okay? Find the geometric mean of 12 and 18. X over 12 equals 18 over x. Cross multiply, do that. You okay with that? Sorry, I don't think I need to multiply it out. All right. The geometric mean of 10 a number is 13. What is the number? Well, where does the 13 go in this case? It goes in for the x's. So that's 10 over 13 equals 13 over x. Cross multiply, 10x equals 169, x equals 16.9. And complementary angles are in the ratio of 6 to 15. Find the measures of the angle, make the equation. So if I have an angle of x, what's the complement of it? 90 minus x. So 6 to 15, so you have 6 to x equals 90 minus x to 15. Cross multiply and solve. So you'll wind up with, 90 equals 90x minus x squared. Is that right? And then doing the math, so you get x squared minus 90x plus 90 equals 0. Do that right? 6 times 15, that should be 90. 90x. Bless you. Bless you. So whatever that would factor down to, or if it doesn't factor, you guys go to the quadratic formula, right? Quadratic equation, depending upon which day of the week you heard it. Good. All right. What do you remember about similar figures? You all know I've given you the picture reference many times. Question for you. Are all equilateral triangles similar to each other?
Yes.
Yep. They all have a 60-degree angle, so they're all similar, right? But are all isosceles triangles similar to each other? No. But the reason why the equilateral is similar is because the angles of every equilateral triangle are always 60, 60, 60. It's just the lengths change. Okay? What does that tell us about the angles of each polygon? They're the same. The sides, there's some sort of ratio between the sides if they're similar to each other. Okay? Using the word similar, that's the little shorthand version to it. I don't know, I wasn't at the meeting when they developed it. Okay, similar polygons. Okay, simple as that. Must name the angles in the same order. So if I said you had a polygon, ABC, or ABCD, and then that is similar to a polygon WXYZ, the A and the W are the same and go through the angles. So the order of the letters means something. So they might have a shape flipped on you, so please be aware the letters that they tell you it comes in is the order it should go in. That's how you figure out the similarity. Don't trust the picture. Can I go? All right. So if ABCD is similar to EFGH, the congruent statements would be angle A. Whoa, stop. Time out. Angle A and angle E are the same. Okay? Remember, congruence is the same. B and F are the same. C and G are the same angle. And D and H are the same. What about the ratios? Well, the ratios would have to go in order. So you could say that AD is proportional to what sides? EH. And then you could say, so that AD, AB, and EF, BC, and FG. And then what's the last one? CD and GH. Those are your similarity statements you could say. Again, it's just relating the sides to the sides. Does it mean the sides are the same? No, it means that there's a ratio that you can determine with the sides. Okay? I'm on the back side, right? Back of the front. Okay, given triangle ABC is congruent to triangle DEF. So ABC, DEF, do they appear that they're in the right order now when you look at the picture? That works. List all pairs of congruent angles. Well, angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. So all those angles are the exact same, being those two shapes are similar to each other. Find the ratio of all corresponding sides. So 25 to 5, 20 to 4, 30 to 6. You could do the flip overs of any of those, but there's other ratios that could happen. Could this one happen? 2, not equal. Could that happen? Yeah, so what I would have done is I would have taken this over this to this over this, keeping the ratio of the letters the same. Okay, I could even take the perimeters of ABC and the perimeter of DEF, whatever those are, and that becomes a ratio as well. Yeah.
Can you also put the colon instead of putting it in some fractions?
Oh, I see. So 25%. Yeah.
Could we?
Yeah.
Does it matter?
If you see it with the colons, please go with it. All right. Given the two triangles are similar, what similarity statements can you make? So what angle goes with what angle? So if I were to say ABC, so triangle ABC is similar to triangle, what's the order I have to say it if I use that?
HGF.
HGF. Does everyone make that work? Because the angle dictates the order we have to say it around. So I could have changed triangle ABC to triangle CAB or CBA or whatever, as long as I can make the other one similar, making the ratio the same order. What can I say about the sides? Well, I can say that AC, I'll just do one of them, AC, which is double to 0, and HF, double to 0. And there's a whole network of them that I could do, including the perimeters. Lucas, next time you have to leave the room, you can leave your phone here, please.
Okay.
Thank you. Scale factor. Are these figures similar? And why? Well, looking at them, they look like they could be scale factors of each other, but we shouldn't trust the diagram. So what's something that should stick out to know that they are similar? Angles are the same. So RD, S to E, F to T, G to U as far as the angles. So the angles could say that. Is there anything else? Let's say we didn't necessarily know the angles. What would you think, Ben?
The sides are like the one on the right is the 1/2 scale of the other one, or no, the bigger one is the scale of the smaller one.
Ooh, I see what you're saying. Okay. Another thing you could look at is this, is you could say 30 to 20. That's that one ratio. 27 to 18. Someone with a calculator, just do the cross product of that real quick. Just multiply those out. 30 times 18 is
It's 540.
540 both ways. Okay, so if you didn't know the angles, then you would have to kind of do that with all the relationships of the sides. Another way you could go about this is you could find the perimeter of each, and the perimeter of each, set that up to a scale factor as well. Let's see what our question mark is. What is the scale factor? What does this scale factor look like? Reduce 30 over 20, so you get 3 to 2. Whoop. 3 to 2 scale factor. Cool. Triangle ABC, GHJ. ABC, does it appear that they're in the right ratio? Find X, found it. Okay, so could I go 12 to X equals 8 to 16? I set it up right? Cross multiply, so I get what? 8X equals how much?
No,
16. Ah, okay, take it for now.
192.
Divide that. 24. Cool, that'll work. Okay, again, could I have done 18x and 12 to 16? Yes. Could I have done 12 plus 18 plus x and then over that ratio? As long as I have two things that I compare that are the exact same thing equal to two other things, then we should be able to do the ratios without any problem. And we have a theorem. Yay! Wait. Where's that one? No, wait. There. Okay, are those similar? 1, 2, 3.
Yes, they are.
So 5 to 10, 6 to 3. Yeah. So yes, with a scale factor 2 to 1, or 1 to 2, depending upon which way you want to go with it, right? Find the perimeter of each triangle. Oh, well, what is that? 8, 12, 12 to 24. Find the ratio of the perimeters. 12 to 24. 1 to 2, 2 to 1. Make a conjecture. The perimeter. So a big jump on this stuff is realizing if I'm comparing line to line or segment to segment, it's a one-dimensional thing. Okay, ready to stretch your brain a little?
No.
The perimeter is one-dimensional. Why can I say that though? Let's say I knew all my sides were in inches. What would the perimeter's relationship be? Inches or square inches? Inches. That's why it says one-dimensional. Okay, it's just the length. And where it starts getting hard is if you teach this too young to people, it's hard to fathom going, how can a triangle be a one-dimensional object? Well, you're measuring the perimeter, so you're just getting a distance. Yeah, but the triangle, no, you're right, the triangle's two-dimensional. But the distance around it's one-dimensional. So that's a little different thought process. Ooh, do we have stuff I can remove? Gotta write it? You kidding me? If blank blank are blank, then the blank other blank equals the blank other blank.
If two angles are the same, then all the angles.
So maybe this, if the angles are congruent, then the ratio of their sides equals the ratio of their perimeters. Sound okay? I think we could skip this one. This is pretty quick. I think you'd be able to do that pretty quick. But then, so remember this as far as, I want you to go back and take a look at the medians. Okay, remember the median is the middle. No, let's just pretend I can draw straight.
Nice.
So the medians dealt with the centroid. So there was a relationship with that. There was a certain relationship that you knew from here to here. And from here to here. Okay? And then you also had one about the altitudes. What's the altitude? The height of the triangle. So remember the height forms a 90. Does the altitude cut the angle in half? No. Let's see. That doesn't look. Whoa. And then last altitude. Whoa. So remember, there's relationships that go with that as well, and they intersect. Okay. So. If blank are similar, then blank, 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 blank. Can I remove? Yes. If two polygons are similar, then the ratio of any two corresponding lengths of the polygons is the scale factor. Examples of corresponding lengths. We could talk about those all day long. But let's not worry about it. So that gives us tonight and through the weekend 6.3 as the assignment. It looks like a front, back, and a front. And remember, the answers are given. Woo! I made it. I could have done better on the medians and the altitudes. I'm sorry.